job is to determine the region, right? What's the region?
Is it the triangle, top triangle? Just like it looks like the bar.
Come on, Joe.
This one?
Call that one.
It's the part right below that.
Go, Joe. There's only two of these, so no dear.
Yeah.
That means we have a tie.
Are you tired right
Not really, because there's really only one opinion that matters,
Sorry.
right? That's my opinion.
Yeah.
So it's not really,
That's why I agree
I'm
with
not a
that.
tiebreaker, just my opinion's the only one that matters, so I'm not breaking a tie. You both could go with the same region, and still my opinion
No,
matters, so we're not breaking a
I
tie.
understand. I'm assuming that one of us is right. Because the other two
I mean, that would be a
options,
pretty
the other two options
bold
seem
assumption.
wildly wrong. The other two options seem like really, really wrong. So
You're right, it is one of those two.
yes, 50-50 chance. Like those nuts.
So what do you mean when you say 50-50 chance?
Well,
It's 25. Because it could be done too. It's not. It could.
Well, knowing that it's one of those
Knowing
two,
that
what do you
it's
mean
one
by
of those.
50-50?
one of us is right and the other one's wrong. So there's
Well, actually, that's a 100% chance.
even odds that.
That's a 100% chance of one of you being right and one of you being wrong.
All right.
Because I told you it's one of those two reasons.
Okay, so then there's a 50-50 chance that one of us is right.
No, it's a 100% chance that one of you is right.
Is that 50% chance you're right?
That's not how probabilities work.
Yeah.
That's not how probabilities work.
It probably is just something.
It's a 50% chance that you randomly selected the right region. That's how probabilities work.
I'm
I think so.
So like. Oh, actually, yeah, it could be two because Y is there. I didn't see that.
Give you suspense.
Suspense is
I think it's two though.
Oh,
Like the
you're
other one, yeah.
Yay. Because it's.
Your triangle is not bounded by the green.
Yeah, I didn't even see that green.
That is the right region, not bottom region. Now we get to describe it. Did you come up with the description yet?
For that region.
Because that was also part of your homework, right?
Yeah,
Not only did you have to select it, but describe it.
I have not described it.
So, how do you want to describe it? Vertical or horizontal?
Vertically, because then you have the axes. You don't have to worry about balance changing.
And so if we're doing vertical, X is going what?
Left to right from what origin?
So what are the bounds?
0 to 8.
As soon as I saw that as 6. Now, might be good what we're doing, right? Now slide this along 0 to 8.
Oh no, the bounds do change because you get to right.
No, you're not wrong. Your bounds for X are the same, 0 to 8.
Okay.
But what did you notice?
There's the intersection points. Well, presumably between.
It's not the same.
Yeah.
upper and lower bounds from the entire. So your x is going to go 0 to 8 over the entire region, but you have to actually split this into 2 regions.
Yeah, 0 to 4 and then 4 to 8. Is assuming that that's exactly 4. You'd have to
It will be.
plug in and solve.
Yeah, it will be. So why don't we see if we can avoid 2 regions by going horizontally instead.
But would you still? Oh no, you wouldn't.
We're going to see if we can. Not if we may still have
Wouldn't it?
2 regions. So if we're going to go horizontally, y is going to go from what, 0 to probably 4.
Yeah, probably.
So slide up. Either way, we're splitting this into 2 regions.
Yeah, I think.
So we're sticking with the vertical.
Probably be,
Yeah.
So-
Either way, we have to do 2
How
regions.
would you split it to 2 regions?
Because horizontally,
Yeah. Because you get to.
yellow to red.
Oh, I see.
Yellow
And
to blue
then,
now.
okay, I see.
Probably shouldn't use green, huh?
That's hard to see.
Let's use. Because green was one of the colors already in, so it's purple. Those 2 regions are non-overlapping, except at the boundary, right? They share a common boundary, but they don't overlap anywhere else. Now, describe each of those individual regions. So give me the description now. When I say description, I don't mean like a word description, description mathematically.
Oh, like it's X and Y?
So it's the set of all ordered pairs x, y such that, to verify that is actually 4, you just look at, okay, where do yellow and blue intersect? Well, blue, y would be 16 over x. So 16 over x equals x means that x squared equals 16. X is plus or minus 4, that's blue, the positive one. So it is B4. And then y is going to go from what?
4 to 8. Oh, sorry, no, 0 to 4.
Y goes from the green, right?
Yeah.
Up to the yellow.
So, Y, okay.
The x, right? Now for that second region, what is x doing? 4 to 8.
Yeah.
What about y?
0 to X. Or sorry, yeah, 0 to X.
Has to be a function of x only.
X over 16, yeah. 16 over X.
There's your description of the region.
So I guess doing the domain helps set it up.
Well, that's the whole setup of it. Because now we have to do this. Remember, if you can write the region as a union of non-overlapping regions, then the integral is the sum of the two. Well, more than two, if you have multiple non-overlapping regions. God, I only have 10 minutes left already. Until the worksheet.
Do we have two categories?
No, just the one. Next lecture, I'll have to a worksheet and then a review worksheet. So I probably won't be able to get through the other two questions. Oh. All the same, really. So I could write them out together. Let's just break them into pieces. Just look at each one individually and then add them up. So remember we did vertically, right? So it's dy dx. Outer is x, was 0 to 4 we said. Inner is y, 0 to x we said, right? Oh, look. That is independent of y. Just be x minus 0, which is x. That's what, x to the 4th over 4? What's 4 to the 4th over 4? It's 4 cubed, which is what? There's your first integral. Incredibly simple. Outers, so against dy dx, so outers for x. Integers for y, and you set it up to 16 over x. And again, independent of y. That first integral is going to be 16 over x, right? Now times that by x squared. So 16x, isn't it? That is 8x squared. 8 squared, 64. 4 squared, 16. What's 64 minus 16? Times 8.
Three, four.
I was looking at the wrong. And what's 64 and 384?
440.
There is your integral. See that?
Is there a time where you do it like vertically instead of horizontally, or
Well, that was vertical.
I mean like in a or like horizontal?
Depends. In this case, it wouldn't have mattered. Obviously, the descriptions would be different if I went horizontal instead. It really depends on also your integrand.
I guess this is just whichever is easiest.
Generally speaking, that's what you want to do. Or again, depends on the integrand. Because if you look at this one, dx, dy, this would be horizontal. What's the antiderivative of e to the x squared with respect to x? No. What function, when you take its derivative with respect to x, gives you e to the x squared? There is no analytic function. Which means that order is impossible.
Yeah, so
But it doesn't mean the interval doesn't exist. The interval exists. So let me rephrase that. It doesn't mean an analytic solution doesn't exist, right? Remember, there's two solutions, analytic and numeric. Every integral can be done numerically. If you remember from Calc 2. When we did coding, remember that?
Yeah.
But not every integral. In fact, the vast majority of functions do not have analytic antiderivatives. We're going to flip the order. But in order to flip the order, you have to redefine the region from horizontally to vertically. You cannot do this. Like, that's not what we want. And I see that happen all too often.
does it change if you change the order? Like,
The region doesn't change.
but like
It's going to
the
be
bound?
a different description. So right now we have this. I'm going to call this the horizontal description. All right, if we read that, y is going to go from 0 to 1. X goes from 3y to 3. Region plot will work. We need the region. We said what? 0 less than equal to y less than or equal to 1. And 3y less than or equal to x less than or equal to 3. And all I'm doing is doing less than and then the equals, and it automatically converts it to that. Now we need viewing window. X, it's going to be quadrant 1. You should be able to easily see that. Y is always non-negative. Well, the lower bound for x is 3y. If 3 is always non-negative, if y is always non-negative, that means x will also always be non-negative, right? Looks like it goes up to 3. Yeah, it'll go up to 3. I'm going to do something I don't like doing typically, and use different viewing windows, use different sizes. There's a reason for that. If I do this, and I think what's going to happen, if I remember correctly, yeah, it's going to frame it, which I don't like. Oh, it actually didn't do what I thought it was going to do. That's nice. Sometimes it curves and doesn't come at a point. Which it's not doing now, which is nice. But what happens is if you then shrink the region, it actually will go back to the points, just however it's how Wolfram is designed, how it spits it out. But this works. Okay, that looks good.
You know, you can just copy and click that. Copy.
I mean, it's a limitation of the online version, I think. I'm actually at time, so I'll just give the vertical description. Now we're doing vertical, right? So x is going to go 0 to 3. Y is going to go 0 up to that line, which is x equals 3y. Write that as a function of x, y equals x over 3, right?
So you just bought the old like boundaries or whatnot, and then you got the new one by like just doing it.
They are now the same integral. And that can be done. So I'll leave that to you for you to do. Perfect. What, you don't have to plot it,
I mean, not plot, but like.
but you have to understand what the region is. And what you're doing is you're not, when we say flip the order, you're not literally just flipping. Right? What it means is you're redefining a region. In this case, it was originally horizontally defined. Now we want to define it vertically, because we want to do dy dx, not dx dy. Okay. Say it was actually 28 minutes.
I got one.
So go ahead and get into your group.
I hate you, bro. I got one. Dude, yeah. I got pulled over on the way here. Oh yeah.
No way.
That's why I was late, right? I didn't get a ticket, right? Because I argued it with the cop, right? Dude pulled me over for doing a 50 on a 45. I was like, dude, you're just looking for someone really cool, right? I'm not gonna be your bitch. I have a dash cam, thank God.
It's actually funny. Oh my god.
I got pulled over once,
But it's still a ticket.
I know. He actually, like, I was just like,
And I parked behind this car, and then I came back like 2 hours later, and somebody parked like almost touching my bumper. I was like,
oh yeah. I was
like,
like,
what the hell?
no,
It was like 11 p.m. and I was like, you know what? I do not feel bad about hitting your car. I was like, I gotta go home.
So a lot of the times, it may be more advantageous to describe your region in polar coordinates, because it's a polar region. Or, and this is the more important one, sometimes your integrand cannot be done in Cartesian coordinates. It has to be done in a different coordinate system. So one of the last examples that we should have looked at, but we didn't have time, is this one. And while you can do this in Cartesian, it is a bloody nightmare to do by hand. But this is stupid simple in polar. All right, so you should recall polar regions described as r theta, right? So you have r being the distance the point is from the origin, and theta is the angle that the segment OP makes with the x-axis. Right, so you have two axes. You have the radial axis and the angular axis, right? The radial axis is just a bunch of circles, different radii, and the angular axes are composed of radians. So, yeah. Right, ray is just a straight line. Right, so that measures the angle from the positive x-axis. Right? So typically, polar region will be bounded by two rays, alpha and beta. And r will typically be a function of theta. Right, but again, that's just distance from the origin. Right. This is, in a sense, Fubini's theorem in polar. Right? So I want you to notice
RDR.
dA, R, dr data. So what do you think the most common mistake is?
Forget the R.
And the derivation of this is done in the video on where that extra R, from where that R comes from. There's actually two ways to do it. I derive it in the video. It's a geometric argument. You could also get it out of if you use Jacobians. But the Jacobian is more general, right? It gives you a general change of variable. This is a specific case of using the Jacobian. Right, so all this derivation is done with a pure geometric argument and the basic idea of polar coordinates, not using Jacobians. You will have to use the Jacobian in your group assignment though. Alright, so let's evaluate this. Now, if you look at this, first of all, if we were to do this in Cartesian coordinates, I'm going to try to start using Cartesian coordinates instead of rectangular, because I don't want to confuse the rectangular coordinate system with the rectangular region. Right, they're completely different. We're going to try to do this in the Cartesian coordinate system. Can't be done. Right, if you do either dy dx or dx dy, that has no antiderivative. Right? So this is a case where you have to use a change of variable. You don't, theoretically, you don't have to use polar if you know the Jacobian. You can use any coordinate system you want, but we just have polar, and it's easiest to see as a polar region. Because, look at the region. It's a disk, which is easy to describe in terms of polar. Right? Now, if I come back to here, the order here actually doesn't matter. dr d theta or d theta dr. However, for the vast majority of cases, we'll be setting them as dr d theta. Because generally speaking, it's easier to find r as a function of theta than it is to find theta as a function of r. I do not need to plot this region. This should be very obvious. If we're considering the entire disk, x squared plus y squared less than or equal to 36, what does theta do? Theta goes from what to what? 0 to 2 pi, right? And how does r vary?
0 to 16, or sorry, 18. 36?
How'd you get 18?
Because I'm looking at x squared plus y squared, so it's going to be 80 squared.
Right.
So
What's the square root of 36?
18.
No. 18 is half of 36. Oh dear.
4.
4?
6.
Oh dear. Oh boy. Oh boy. I think I need to give you a pink slip. Go back to, that's a times tables, 4th grade. Oh dear. Didn't know what the script was. It's okay, it's one of those days. Just say you should have taken your prescription when you did.
Exactly.
It's messing with you. See, that's what you need to use that as an excuse. So that's my excuse, I'm sticking to it. There's the polar description, right? do like multiple integration, no problem. But doesn't know that 6 squared is 36. It's generally how math works. You have no problem doing the actual calculus, but you forget that 2 plus 2 is 4.
Mental math.
Always the
Six
algebra.
sounds good.
It's the arithmetic that screws you up.
Always the algebra. Always the algebra. Algebra is evil.
Or, and I've seen this,
Just adding mistakes.
negative, and then the very next line you forget to carry the negative down. So here's what we do. It becomes an iterated integral. I'll worry about bounds later. What is the integrand of the original integral? All right, so remember, what is an integrand? That's right. And so what's the integrand of our integral?
It's. If you go back.
0.
No, you really shouldn't be determining the integrand.
So that's 0. So
That's not the integrand.
Are you talking about the?
oh.
That's not
It's
the
x squared plus y squared.
Yes. The integrand is what are you integrating?
Oh.
It's the function.
Yeah.
So
I thought
you said the integrand, x squared plus y squared to the 3/2. You have to write that now, because that's a Cartesian relation,
Can you convert it?
or a Cartesian function. You need to now write it
Oh,
as a polar function.
R squared 3 over 2.
What was it?
R squared bracket 3 over 2. Is that x squared plus y squared and R squared?
So how does that simplify?
2.
Is what?
2 times 1.5. I don't know.
Oh boy. This is second grade.
2 times 45. 3? It says 3 point.
Yeah. 2 times 3 over 2 is 2 over 2
1.
times 3.
I had so easily calculated.
R cubed. You're not allowed to take minus in my class anymore.
Can you also like add the, you know how it's RD theta?
Yeah, I'm not going to do that until we're very comfortable with it.
Okay.
So I'm just breaking it down step by step. So that's the integrand. Now you need to convert your differential, right? Your area differential. In Cartesian, it's dy dx or dx dy. In polar, it's r dr d theta or r d theta dr. Again, typically we'll stick with the order dr d theta, which means when you're integrating that inner integral, it's with respect to what?
Yeah.
So what are the bounds? What are the limits of integration for the inner integral?
0, 6,
And what about for the outer?
0,
There's your integral. But the order doesn't matter. So look at this, and this is typically how I approach these. So look at the integrand, r to the 4th. Is that a function of theta? Look at your limits of integration for r. Are they dependent on theta? No, right? So if I just integrate with respect to theta, it's just the length 0 to pi, right? So it's actually just that integral. Arc to the 5th over 5. What is 6 to the 5th power? You didn't know that was okay.
Actually, no.
Double
If I was struggling with 2 times the half,
Mm-hmm.
6 to the 5th is kind of like out of it.
it. Now, double it, because you have to multiply by 2.
50,500.
Times pi, all over 5. There's your integral. Yeah, no, we leave it exact.
I mean, it'll still be exact. Huh?
Oh, wait, that should be over 5, not 2, sorry.
Oh, okay.
Find the area of the region that lies in the first quadrant between x squared plus y squared equals 36 and x squared minus 6x plus y squared equals 0. And they tell us it's in the first quadrant, right?
Yeah.
So here we go. And it's between those two curves, right? So what we're looking at is this region. In here, right? When you look at this, and remember, what is area? What's area of a region? Well, it's area of a circle I'm talking about, just a general region.
For a circle or? Okay.
No, I'm just saying general region. If I ask you to find the area of a region, what is it? That's where rectangle.
Isn't it the lower bounds? Is it the upper bounds? Like it's the variant of the. Oh wait, no, we said this last class. Hold on. It's the bounded area under the curve, right?
That's the definition of an integral summed area.
What's going to be the thing?
Oh,
thing?
double.
Yeah.
It's just the integral of the area differential.
Say that that's volume though?
No,
That's triple.
Didn't we say the double equals one?
it's a sine volume. But that's,
Oh, but that's only if you're taking it with a function.
Right.
Okay.
because then you have to solve it.
Okay.
If it's just this, you're just integrating the area differential, it's an area.
And
Just like if you're just integrating a length differential, it gives you length, right? Integral from 0 to 5 of dx is just the length of 0 to 5, which is 5.
so we're triple the volume.
Yeah.
Or a sine hypervolume, but we'll get that because we will discuss triples. So we want to describe the region, right? Well, you should look at this and immediately think polar. So we have to look for limits, well, I don't say limits right now, bounds on theta and bounds on r, right? So we want the limits of integration for r and theta. So let's start with theta, because that's generally the easier one to look at. So instead of a horizontal or vertical bar, you draw what's known an imaginary radial bar, right? Start at the origin. And now remember what this bar is going to do is it's going to rotate. So as we rotate through this region, what are we rotating through? So theta goes from what to what?
Yeah. I would.
Theta is going to rotate 0 to pi over 2. That's how we're rotating. Now, as we rotate from 0 to pi over 2, r is going to go from what to what?
But 6 to 6. 0 to 6, right? Oh, x squared minus 6x plus y squared 2x squared.
Well, no, because r can't be a function of x and y.
Oh,
But
the polar region.
the idea is the same. It's going from the yellow curve to the blue curve. But we need to now define that in polar. So write that yellow circle as a polar relation. Right? So it's going to be r equals something in terms of theta. Well, if we do this, to start off, right? Just write it as a polar relation right off the bat. R squared minus 6r cosine theta is 0. You'd be able to factor out the r, right? And you get two solutions for r, which you get r equals 0, and r equals 6 cosine of theta. Well, isn't 0 part of 6 cosine theta? So you can throw out the 0. So that called the inner curve. The inner radius is 6 cosine of theta. What is the outer radius? This one is actually easy.
R squared equals 6.
R squared equals 6.
Or sorry, R equals 6.
It's just 6, right? That one is pretty obvious. There's your polar description. Right, so if Rubini tells us we can write this as an iterated integral, convert the integrand to polar, What is the integrand?
Or DR.
That's the differential. What is the integrand? What are we integrating? One. Which means in polar, it's still one. Now, convert the differential. So you want your area differential written in polar form. So now the integrand is R. We now need limits of integration for R. We said that was 6. Cosine theta 6. For theta, 0 to pi over 2. There is the area setup. Now evaluate. Sadly, R is dependent on theta, so we can't do theta first. R squared over 2, right? And then 36 minus 36 cosine squared. Just divide that by 2. 18 minus 18 cosine squared. In fact, I have an 18. But 1 minus cosine squared is what? Reduction identity. Pi over 2 minus antiderivative for cosine of 2 theta, sine 2 theta over 2. What's sine of pi? What's sine of 0? 0 minus 0 is 0. Over 2 is 0. Your area is 9 pi over 2. Easy. Would this be done in Cartesian? I don't think so.
Can you use on a calculator, is that right?
May not. You have to be careful because sometimes it'll just run into an infinite evaluation. It will force you to abort it. Sometimes it won't. I don't think this can be done in Cartesian. X would go 0 to 6. Y would go square root of 6x minus x squared to 6. Yeah, that's not going to be able to be done in Cartesian. You can do the dy, but you're not going to be able to do the dx. And you won't want to try and write this as horizontal. Because you have x squared minus 6x equals y squared, you need to write that, or equals negative y squared, you need to write that as a function of y. So you need to solve for x, and that's just hideous. Yeah, so this would have to be in polar as well. No, so they want us to plot this and then find an area. So here we're going to use the polar plot. Right, this allows us to plot a polar relation. However, the relation has to be in the form of r equals f of theta, which I think it gave us, right? It was 1 over 4 cosine theta?
Yeah.
Or a quarter of secant theta. Same thing. Oh, I'm going to need this because they also want r equals 1, right? And they told us theta is going to go minus pi over 2 to pi over 2, right? And that's it. I am going to do this though. I think that's all I need. Oof, that's rough. So here's what I'm going to do. Turn off the text just to clean it up. I think there's a way I can adjust the viewing window. I just don't know what it is off the top of my head. And if I remember correctly, the last time I tried to look it up, it wasn't obvious. But I am, say, 60% confident that there are options in the polar plot that you can use to adjust the viewing window. Because there is a way I can turn on the axes, the radial and polar axes, but they're not really useful. Right? Generally, even when you do polar plots in like algebra, you generally never plot it on the polar axes. It's always on the Cartesian axes. But we don't really need it anyway. This viewing window is good enough for us.
Oh, it's, I think, list polar plot. Nah.
No, list polar plot's it's going to plot a bunch of points, which I don't think I want. I'm going to want a command within the polar plot itself. And I'm sure there's a way to do it. It's just, for this, it's not that important. Why didn't you give me the option to...
Oh, I think you can just type in range, and then,
There it is. Well, plot range should... If I do this, it should just adjust the vertical. I'm almost confident there is a way of adjusting the horizontal as well. But I'm not going to go -1 to 1. Let's go -1.5 to 1.5.
so that should be plot going.
I don't think so. Yeah, it's not. If it was, it would turn black. Is this an option? No. Yeah, I'm confident there is one. Oh, you know what? What I have to do is adjust the theta here. Probably. I don't think there's a way, there might be, to extend that out. Like, I don't want the x-axis to go 0 to 1, for instance. I'm pretty sure the way I can get it to go like 0 to 2 or something. I just don't know how to do it off the top of my head.
Polar axis, origin?
No, polar axes would be the radial and
Okay,
the
okay, gotcha.
rays.
Documentation is huge.
That's why if you know how to use it, I will show you how to do it. I'm just going to look up polar plot. Details and options. Here's all my options. The axes, origin, expression, points and data to exclude. Control maximum measure points are determined, placement.
There's a range, but we already have.
Yeah, that's plot range.
Yeah.
The range of values to include polar axes, whether to draw the polar, I don't care about that.
Oh, could you plot range and then arrow into x min, x max?
I don't know if that'll work. You know what I could do? But I could do this.
Yeah, that's just what they did, yeah. But they ran into plot range instead of this axis.
Actually, no, that won't be an axis true, and then. Except I have to do this, right? Negative 0.5.
Oh, okay, okay.
Hold on. What happened? Did this, right?
Yeah, but then the see, or one is gone. It switched the legend, and then one of the things is missing.
It's not showing me this. Why is it not showing that? Why did it not show that on the original?
But it showed when you did that. But that's weird.
Oh, duh. Seeking of zeros undefined.
Oh, yeah, okay.
That's why. Okay. So I will go negative because I want the x-axis there, yeah. So that would work. Except I don't like that scaling. That doesn't look like a circle.
Yeah, it's like so. Yeah, it's like a whole thing.
I have to go pick my brother. I'll see you guys.
What I could do, I guess, is this. But that's still more oval.
Yeah.
I don't know why it's doing that. I know the way I can change the scale. It's not here.
ChatGPT is saying for if you want to control the Cartesian coordinates, they use range, thought range, sorry. No?
It shouldn't work. Yeah, that won't work. Because plot range is only the range,
Right.
the vertical. Oh, hold on. In here, I forgot to take out that plot range. Okay, it's still gonna give me that.
Oh, you have the range.
There's a lot of things you can do. Oh, ticks are on. That's interesting. Because I know I can do this, for instance. But if you look, they're not scaled the same, I don't think.
Yeah, they're not.
And I think that's what's throwing it off. If I scaled everything to be the same, it'd be circular. There's gotta be more.
Would that be the padding then? Oh, never mind, scale.
That's a different scale though, that's not what I want. I want to scale axes.
Rescale?
Okay, too complicated. It's going to be aspect ratio that I want. I'm pretty sure.
Yeah.
Oops. So I'm going to want to change the aspect ratio of probably this one. What's full?
It's kind of circular.
Well, I think worse. So I want it to be larger.
Oh. Yeah. But intervals are still,
Victory is mine.
yeah. It's big.
I guess that 2 makes sense, right? Because I'm only half the x-axis versus both of the y.
Right.
Yeah, that makes sense. Victory is mine. I knew there was a way I could do it. I mean, that doesn't. It did shrink the x-axis. It didn't. I was hoping there was a way I could scale
Right.
the x, but whatever. This will work. I don't care. I spent too much time on that, but I only have one more problem after this one, so it's fine.
You also need to set Bing as your default browser. Or sorry, default engine.
What is it?
Bing
Microsoft.
recommended browser set.
Oh, go away.
The survivor
Using Bing, like, I don't even know how Bing is still operating.
There's only one. There's only one more after this.
Like Bing and like Firefox too. Like I don't know.
Firefox is amazing. What do you mean? It's the only other one that doesn't use Chromium.
So here's what we want to do, right? So there's the plot. We want area inside the curve, r equals 1, but to the right of r equals 1 over 4 cosine theta. Right, so we're looking for,
So if we're integrating, can we just interchange it to
That-
secant theta?
it doesn't matter. 1 over 4 cosine is the same as a quarter secant. We're looking for that area, right? Well, again, remember, area is the integral of the area differential dA. Oops. Such that. R is very easy to see in this case. Right? Because it's already in polar, we don't need to worry about it. But now, how is theta going to vary? Right, so again, you draw your radial bar. Starts down here, right?
Yeah.
What's that angle? And it rotates up to here. What's that angle? Right, so the rays we want I'm not using that as a measurement. I'm just going to help me draw a straight line. So those would be the two rays, right? Well, it's where these two intersect, isn't it? So it's where secant theta over 4 equals 1, which means secant theta is equal to 4. Or cosine of theta is equal to a quarter. What's theta? Well, I know theta is going to be a pop. But then this angle is going to be the negative of that, because we're going clockwise. What I'm going to do is I'm going to say psi b that, just so I don't have to keep rewriting it. And then R is going to start with the blue. Go out to 1, right? That's that. Which, I'm going to be completely honest, I do not feel like doing by hand. So this will probably be a good time to show off how to do this on Wolfram.
Do you put integral and then another bracket and then another integral, or is there a double integral?
First, I'm going to define psi. Now, this is where it's weird. Do the outer first. Now the inner. You could do a double integral. You could do
Oh, okay.
a nested. But, and that's actually how it used to be done until they added the multiple integration feature in already. But again, you have to do your outer integral limits first, then the inner, if you're doing it that way. There it is.
Is there a reason why?
That's just how it's programmed. Right, it's kind of like asking why is the spelled THE. That's just the language. So that's just the Lisbon language. That's what we want. There's the area. Now, on your calculator, you would have to do a nested integral. Or you have to do menu calculus. So the menu for 3, I believe. 4 is calculus, 3 is integral. Right?
Then how would you,
And then, when you're inside that other box,
Yeah.
menu calculus integral again. Right, because then that's saying it's the integral of an integral.
gotcha.
That's how you do an iterated integral. And if you had to do another one, right, you do that again. And then you just have to put in your limits.
Okay. Makes sense.
But really what I'm more concerned with is understanding the setup. So is there any questions on how we're setting these up? Like, do you understand how we're getting the limits of integration, how we're defining the regions? Because that's the hardest part of these, not the integral itself. We want to convert this to polar and then evaluate. So here's what we want to do first. Let's first describe the region. It's a Cartesian region, right? Well, look. It's saying, right, that so if we just look at this, I'm not even going to worry about plotting it right now. We know that we're in quadrant 3. Both y and x are negative. But look at isn't that this? What kind of shape is that? More specifically. What kind of circle?
Circle, radius.
More specific. There's an infinite number of circles of radius, right?
In quadrant, from the origin, right?
Center of the origin.
Yeah.
The y matches up, right? That means both x and y, if you're just looking at that circle, would go 0, 3 on the positive end, -3 on the negative end, right? So that matches up.
Yeah.
So the curve that we're looking looking at is a quarter circle. Specifically, it's the quarter circle in quadrant 3. Oh, well, that means R goes 0 to 3. What about theta? What are the bounds for theta in quadrant 3?
Pi and 3, 5, or 2.
Then you just subtract the region polar. You could have plotted it and seen it, right? But just a basic understanding of the shape means you don't have to do that. I'm not rewriting that integral. So I'm going to call it I. What's the integrand? Not convert the polars. What is the integrand?
Y over x squared plus y squared.
Write down the polar.
R sine theta, R squared plus 1.
Now your differential. Remember, this whole thing, dx dy, is dA. That's the area differential. What is the area differential in polar?
RB, RB theta.
There's your integral in polar. Now, actually, no, it would be this, right?
RB theta theta.
I multiply by that.
Yeah.
That would be the fully simplified, right? Now we have to integrate that. Well, we can integrate with respect to theta first, right? The order doesn't matter. Right, this is actually one of those times where I probably use that property. Isn't that integrand a function of r times a function of theta? Which would allow us to write it this way.
C and separated.
As a product of two single integrals. Right, so if we're doing this by hand, this is probably the best way to look at it. Antiderivative for sine, negative cosine, which means I'm going to flip the order. What's cosine of 3 pi over 2? What's cosine of 3 pi over 2? Oh dear. Oh dear.
0.
It's 0. What's cosine of pi?
No.
Other side, negative 1.
Negative.
So that's 0 minus negative 1. Just 1. Oh, that's easy. Okay. This evaluates out to 1, which means all we're left with is that integral. How do you do that integral? Huh? What would your u be? What's du? Is there 2 RDR in there? Nope. You saw this one.
Or just be R then?
You'd be left with u squared over u squared plus 1 du, which is the same level problem, just a different variable. Oh dear, you forgot calc 2? Oh, that makes me sad. Especially you.
Yeah. Always like trap at choosing the method.
Partial fraction
Oh,
decomposition.
I hate that one so much.
That one's not that bad though. That's like the A.
A over B,
It depends on the denominator.
But this denominator's not too bad.
It's r squared plus 1, which means you have
A.
AR plus B over r squared plus 1. Oh, but wait, that's not the first step of partial fraction decomposition. First step is to make sure that your rational function is proper. Is that proper? What does it mean for a rational function to be proper? What's the definition? So start even more basic. Think of a fraction. What does it mean for a fraction to be proper?
Okay, start.
Is that proper?
Yeah.
Is that proper?
No. Oh wait.
Yeah.
Yes.
Is that proper?
No.
You said 2 of them were proper?
Yeah.
Okay. Only one of them is proper.
Oh, is it when
Three of
the
them, right?
numerator?
Numerator is strictly less than the denominator. That's proper.
So
Now put that in terms of a rational function.
in this case, then
It is proper,
it is proper.
because of the plus one.
Degree of the numerator is strictly less than degree of the denominator. What's the degree of the numerator?
2.
What's the degree of the denominator?
2.
That's improper. We have to make it proper.
Can you just do r times r?
How is that done? You said it.
Oh,
Mixed fraction, right? So you can make 5/4 proper by writing it as 1 and 1/4. That's what we have to do here. Polynomial long division.
dude,
That's
I always forget how to do that. Like, I'll learn it, and then, like, I'll forget, and then I'll learn it again. I think I've done that, like, 5 times now.
so we go in once, and then we have a remainder of 1. Are you getting it?
So just keep on flipping.
And then no, I'm forgetting what we do for this case.
So, no,
Isn't
so
it-
no, minus.
Oh, that is sexy.
We can pull up, so we can pull up 1.
Integral of 1 is just going to be the length of the interval. What is the antiderivative of 1 over r squared plus 1?
The natural log.
Nope.
Or, wait, why couldn't we just use some?
What you get?
Oh, never mind, because I was.
Could you just, bring the denominator
Nope.
to the top? Now you can question mark.
Nope.
So,
Inverse tangent of r.
it's always true.
It's a known antiderivative.
Yeah, it's on the,
What's the derivative of inverse tangent of x? 1 over x squared plus 1. Which means the antiderivative of 1 over x squared plus 1 is the inverse tangent of x.
right.
I don't want to call that an elementary function because I don't think inverse tangents, by definition, is elementary.
We should know that.
But it's a cap 1.
Yeah, yeah.
It's elementary in the sense that you already know what the derivative of the function is. So it just matches up.
I always forget.
So that's the inverse tangent of r. What's the inverse tangent of 3? Oh, no idea. It's just the inverse tangent of 3, right?
Some. Right. That should.
And what is the inverse tangent of 0? 0. Which is not what I have. Did I do something wrong? antiderivative of sine is definitely negative cosine. Right, so you go, I did, that should be negative 1.
Oh, okay.
Oh, sine error.
I mixed it up. When I flipped the order, I still did 3 pi over 2 minus pi, and I should have done pi minus 3 pi over 2. That's negative 1. So that's going to flip. That's going to make this negative, this negative, negative. There's your number.
Always trig somewhere in that.
Trig algebra always knows the
Technically, it's not trig.
I mean, not trig, but.
That's inverse trig.
No. Okay, yeah.
Which technically is not a function.
Okay.
Right? If you think all the way back to pre-calculus, technically speaking, the trig functions are not invertible because they're not 1-to-1. Right? Remember what we did? We just restricted things to make them 1-to-1, and then said, oh look, now on that restriction we have an inverse. Right? So technically speaking, the inverse tangent is not actually a function. Because tangent itself is periodic,
Yeah.
which by definition means it's not 1-to-1. Which by definition means it cannot have an inverse function.
It's gotten to the point like when I do questions now, I'm always like double guessing. I'm like, oh, is this can I change this to like sine or cos or tangent or something?
Right, so we just kind of did some voodoo to say, oh, the trig functions are invertible. Kind of like, woo, they're invertible. Using voodoo, dark algebra. My favorite professor used to say, dark algebra. And he'd always do that too when he use that go. And by dark algebra, it's this. Did that a lot in my cosmology class.
Like,
Imagine
oh no,
they
I
draw
feel-
dark trig.
I feel like so many things, including that,
It's
were
dark.
so much more interesting, like, historically, because,
Then you should take history of math.
like,
Is that hard really?
But it's a junior level course, so it's not all for you.
like, I don't know, I feel like if you were to prove this, there's no, like now we can just look it up and verify it. But like, if you were to prove this and then take it to somebody and they were like, no,
I never took history of math,
I
but
feel like they
I was pretty close with someone who teaches it. And it's really interesting.
I was
The way he taught it was more of, like, you go to the history of math, so it treated like a history class, but he focused more on historical problems, how the problems were solved historically. So he kind of looked at the historical problem of Newton
see
and how it came about calculus.
That's so
I like the history
And how he
of,
solved some of the more classical calculus problems. That's how he did it.
the history of the like mathematicians and like physicists and stuff are
It's
so
so cool.
interesting
so cool.
because they're always like the most insane people.
Like there's this one guy.
But they also do
Galois.
historical proofs.
There's this one guy, Galois, he's so super smart. I think he died around like 18.
Galois,
Yeah. He died at 18 or 19 because he did a duel.
Galois theory.
Yeah. He got shot.
So my favorite
That
guy-
is, so there's a branch of abstract algebra called Galois theory
Yeah.
dedicated to him.
my favorite
Even though, funny enough, abstract algebra was after his death.
my favorite, like, I think he was a physicist, is Tycho Brahe? Tycho, I don't know what his, I'm forgetting what his name is, like what his last name is. I pronounce
Imagine
it.
if he just didn't do the duel.
Actually, a really good mathematician study. I'm going to guarantee you this kind of thing. Ramanujan,
Oh yeah. Negative 1 over.
he's interesting.
Yeah.
But that guy, so this guy was nuts. He was a physicist, an astronomer, and like a mathematician during the Renaissance. And one of my favorite things about this guy was he would throw like ragers at his house. And during one of them, and it was all like a bunch of colleagues of his that would show up. But he was like notorious for getting like shit faced.
So before I forget, third group assignment, had the dates been updated on Blackboard? However, I'm not sure if I'm going to change the due date again until later. Because going through the syllabus, I realized I actually forgot triple integrals. I skipped triple integrals and went to triple integrals, cylindrical, and spherical.
Oh,
So I had to add that back in.
Can you just make that another assignment?
So this due date's probably going to get pushed back. And I don't know if I want to actually do a group assignment on vector analysis. So this might be the last group assignment, in which case I may push it back, the due date back to the end of the semester.
Okay.
But you'll see that reflected on Blackboard. I'll make that decision at a later date. Quiz board will go up after next class,
Monday.
after Monday's class, and obviously we do just before the exam. Second exam, don't forget the bonus opportunity, that's due the 23rd.
Quiz is due before the.
It'll be due before the
Yeah, 1
exam.
o'clock.
It'll be due 1 o'clock to the 23rd of July, which is just before the exam. And the second exam is the first 100 minutes of class on the 23rd, which is next Wednesday, so don't be late, because you won't get extra time. Right, so it'll be 100 minutes. So actually, here's how next week's gonna work, right? Monday, first 30 minutes will be the worksheet on polar integration, right? Then we'll do a 5-minute break, and then 100 minutes of the exam to review worksheet,
And full liquidity on there, right?
which just like the first exam, is a really good reflection of what the exam's gonna be. So you may want to take that review seriously. So that will be Monday. Then Wednesday will be 100 minutes. The first 100 minutes will be the exam. 10-minute break. Then we start triple integration. And exam 3, I have to make it comprehensive, but it's going to be a heavier focus on triple integration.
are we getting?
Okay, so I think what I'm going to do, it's 120
Wait,
minutes.
it's exam, it's exam through the final exam.
Yeah.
So it'll be 100 points. I'm thinking 100 points. But either way, it'll be 60% new material, 40% old material.
Percentage wise, how is it compared to exam 1 and 2?
So it's going to be weighted more
Well, count.
because it's going to be more points. So I don't have it set up that way. I have it set up, the exams are total, what did I have it set as? 45?
Yes.
But it's total. So it takes all the exams, sums up how much they're worth, sums up how much you got, and that's the percentage. That's your grade, and then it's 45% of that. So because the final exam is going to be worth more points, because I'm just summing everything up, it's actually weighted more within that category than the first 2 exams.
Okay, awesome. Alright.
See you,
Yeah,
Chad.
you remember John, this guy, the way he became here later.
See you guys.
So that was a great weekend, except for you two.
Yeah.
I have a-
See you guys later.
Can you answer a question that I have about linear algebra?
Oh, what's that?